We had been talking about wings and what allows our birds to take flight and stay there. So we talked about wing shape and airfoil and sort of all that business. And so at the end of class, we've been talking about the primary feathers and slotting on those primaries. And so what I want to start class with today is a little bit of review of that. So let's start with what types of birds would we be most likely to find that slotting in? Right, so we have in here is a goose, a falcon, a bird of paradise. If you're going to like a bird of paradise is one worth liking. And an albatross, or a large seabird. The largest, in fact, of all seabirds. So let's take a hot second. Think about the birds that we have available here. And knowing what we know about slotting, which ones would we be, which, if any, or if more than one, would we be most likely to have slotting in? Oops. Okay, well, let's start from our least favorite, our poor little bird of paradise. So this is correct. Our poor little bird of paradise does not, or is unlikely, to have slotting. Why do we think the bird of paradise does not have slotting?
Well, it's not a predatory bird, I would assume.
It's not.
So, I feel like the slotting usually occurs in predatory birds who have to make sharp turns when chasing prey. That's not really an option for birds.
Okay, good. So remember, one of the keys with slotting is this is all about sharp turns in general, okay, which our bird of paradise really is not doing a lot of. Okay, in addition, our birds of paradise, we can even tell from this photo, tend to be much smaller. They're much more songbird size. So even for sharp turns, which all birds do except for one on here, generally speaking to some degree. And when you're a smaller bird, sharp turns, generally speaking, if we even think of something we're probably more familiar with, like a sparrow or a robin, when you're a teeny bird, those are kind of easy to do anyway. Right, so we don't need any special features that allow us to do that. Right, so he's already well equipped. He's good, so we already knew that wasn't a problem. All right, our albatross was also not the most popular, so if we did not vote for the albatross, why not? Where is the albatross living? They do, right? So the albatross is a marine or a sea bird. So why might they not need to worry about this as much?
Open area?
It's an open area, right? And so one, as we think about If we're a seabird in a big open area, what are they likely eating? What do most seabirds eat? Fish. All right, so the type of prey that you're chasing are going to be significantly different. So we're not going to go through any aerial battles or any aerial chases to get our food. All right, we're going to be diving to get fish. So we aren't going to need any hardcore quick turns, right? As we sort of mentioned as an aside here, which is not necessarily something I would require you to know, is the albatross is one of the biggest birds, right? In fact, it has, as a fun fact, the largest wingspan of all birds. So you could slop the crap out of this bird. It's still going to turn slow as all daylights. It's just too big of a bird. All right, this bird crash lands. It's too big. So this leaves us with our last two choices. All right. So our most popular choice here is the falcon. All right, why would we choose the falcon as a good choice? Or this is our most popular. All right, so if you chose the falcon, why did you choose this? So it's a predatory bird. What's it likely hunting? Lots of small, so I heard rats, mice, other small birds. Okay, so these are things you're going to chase, right? So when you chase things, being able to move fast and turn fast is going to be super important. So our falcon is a good choice. In this case, it's our best choice, right? It's the most predatory bird. It's also the chasiest of all birds. Okay. We also have the duck, goose. Goose, that's definitely a goose. On here as a choice. If you chose the goose, why did you choose the goose?
Because they're larger, so like the slits in their feathers would make it easier for them to find.
All right, so goose or geeses, gracious, I'm tired. Geese and ducks, right, of similar type are larger birds. They're chonky birds. All right, so slotting would help them move, but they're not so big that it would be impossible to turn. Okay, where do we find things like ducks and geese? In big water or little water, though? Little, right? Because remember the key here is this was an ocean. Okay, but this is a pond. What do we have around ponds? Where do you find an average duck? Also on land, right? So we do find them in ponds. We also find them in like forested areas. Okay. So some ducks and geese do have slotting as well. Okay, because it does help them maneuver and find their food or escape predators within obstacles. So this is also a good choice, right? If you were to see this on a test, you're going to see a falcon and a duck probably not listed. Okay, but both do also have them. Okay. But since our definition is slotting helps with things like tight turning, we usually see that as catching prey, but it can also help us do turns if we're a big old fat bird, right, like a duck or a goose, trying to get around difficult obstacles as well. All right, so does slotting make sense, how it can be useful, where we most commonly find it and where it can also be useful as well? Any questions about slotting? Or, of course, any of our feather conversations that we had at the end of class last week. Holy cats, it's Monday. So remember, the key with any of this is all in our primary feathers, right? So primary feathers are all about being able to take off and control flight. Yep, I'm just drawing on that. Nothing's happening. Let's try that again. So rude. Thank you. So we want to compare this to secondary feathers. So remember our primaries, let's put that line back in. We had this in green. Almost got me today. Our primaries was everything to the right of this, right? They were all inserted to the hand. These are stiffer, more asymmetrical feathers, okay, that are key not only to being able to take off, but right, this is where our slotting and stuff goes if we are slotted. Okay, and we can only lose a few of those primary feathers if we are to be able to fly. So we talked about things like pet stores, doing wing clippings, right, or birds needing to be worried about being injured here and not leaving them grounded. Now, feathers can regrow, but it's a very high-risk place to be hurt. Now, the secondaries is everything else, right? They kind of make up the cape of our bird. And that's quite a bit how they end up functioning. So they fill in everything else, right? From the wrist to the armpit, or the elbow is appropriate. Okay. And so these are the much softer of the feathers. Okay. Often the ones that you tend to find, if you find feathers laying around, these are shed much more frequently. Okay. They grow back much more frequently, right? They make up the bulk of the arm. Okay. If a bird is going to get grabbed, right, and you're going to go, as an animal, you're going to get the bulk of the wing here. Okay, that's going to be all of this stuff. They're easier to pull out. And it's not as big of a deal if we lose some, since these aren't the stiff, push down and get off the ground feathers. Now, it's not to say they aren't important. Right? The key here, as these secondaries, is once the bird is in the air, right, these are going to create a single sheet. So when we think about birds preening, right, we're going to pick up a little bit of oil from our uropygial gland, right, and we're dragging our beak, still not drying, all along these feathers to zip them together. We want to keep them straight and flat, kind of like when you're making your bed, right? We want everything lined up nicely. To create a wall or a sheet or a cape of all these feathers together, they're going to keep our bird in the air, right? Keep that lift, right? So we have the high pressure airfoil below and that low pressure airfoil above. And that only works, okay, if we have that nice continuous sheet of feathers that maintains sort of that wall of below and above. All right, so that's really the goal when we see our secondary feathers. So we can lose some, but we can only lose some up to a point before we end up breaking that wall and too much air begins to escape through.
Do they preen the primaries at all?
They do. They preen both the primaries and the secondaries. All right, we can't have any totally damaged feathers. They do all need to be going the same direction, more or less, for them to work. But when we're really preening, the key with preening in particular is maintaining this sheet so we can maintain being airborne. But you're correct in that really any bent feather is ultimately going to ruin being aerodynamic and going to create more energy required to move. Preening also serves other functions. For example, if I'm a duck, right, I want to preen because I can also put like a waterproofing oil on my feathers that will keep me from becoming waterlogged when I get in the water, for example, right? So printing has many functions, but one of these main functions as we think about the wings is to help maintain that aerodynamics, maintaining that airfoil that we talked about before. Okay, the difference between primaries and secondary feathers is very clear. Okay, so both are important, but they're serving ultimately very different functions as we think about what gets us in the air and what is going to keep us in the air. Oh, yep, we did that. I did that already. I removed the endothermy stuff, so if you're following along with my sheets, pop ahead. So, bird respiration. So we had an idea when we were looking at the anatomy of our bird that there's something really special going on with the respiration of the bird, right? Because they had regular lungs, right? Sort of like what we imagine regular is not fair, right? But more mammalian-looking lungs, okay? But they also had several of the air sac type things, sort of like what we were seeing in turtles, etc., as well. Right, and so the reason for this is because of birds and flight, right, they are using a lot of oxygen, right, to maintain their muscle movement, right, and we have to imagine in order particularly to do any sort of long distance flight or just to do takeoff, right, they are using a lot of muscles and some powerful muscles, and they need to maintain very efficient aerobic respiration at all times to make this work. So of all of the animals that we're going to talk about, birds have to have the most efficient continual oxygenation method. So ultimately what we're going to find is, in combination with these lungs and these air sacs, remember our pigeons, for example, had 9 different air sacs. Most birds have something between 5 and 9 sitting in their bodies. Okay? Birds are going to use a combination of both positive and negative pressure breathing in order to get continual oxygen flowing through their lungs. Right, whereas most of us have a pause with a deoxygenation step in our lungs at some point. So here's how they get basically this continual flow. Okay, the first thing we're going to know and we kind of can think back to is out of all of the animals we looked at, most animals had that diaphragm, right? We have one, turtles had 2, right? Birds didn't have any. Okay, so this is where the use of the positive pressure sort of comes in and steps into the role that the diaphragm played for us, or plays up, right? We still use it, we still breathe. So as such, when we go through this, the birds ultimately have a 4-step process instead of a 2-step process to make this work. Okay, so in other words, they need 2 breaths to completely clear out of everything, right? A whole inhalation, exhalation, that's step 1. Then a second inhalation, exhalation to completely go through their whole body. So let's look at how this works. So our first rotation. So inhale 1 and exhale 1. Okay. We're always going to trade off going back and forth between using negative pressure and positive pressure. Okay, so our first step looks like negative pressure, very much like it usually does, right? Like it kind of does for us. Okay, so we have to start getting fresh air into the body. Okay, so remember with negative pressure, Okay, the keystone of it being negative pressure means everything's going down a concentration gradient, right? Specifically a pressure concentration gradient. Okay, so the only thing we have, remember, we don't have a diaphragm, but we still have rib muscles. That's what these costal things are, right? The muscles between our ribs, right? And our bird had plenty of rib muscles. So we're still going to use those, right? We contract our costal muscles. When we do that, that makes our chest bigger. And as soon as we make our chest bigger, right, a bigger space, decreases air pressure. Okay, as soon as we make our chest bigger, okay, then our air is going to go down that pressure gradient. Okay, so the key here is the first place that air goes is as posterior as possible. This is a good way to practice our words. Remember, posterior means low, right? So it's headed to the butt sacs. So we see this here in this figure, right? That's step one. So our first inhalation basically ends up filling all of the sacs down by the bird's bottom. Okay, this is more than one sac. This is an image. So if we remember all of the things we saw in our pigeon, right, usually there was 2 to 4, okay, down in the lower half of the abdomen. Okay, sometimes they're literally down by the femur, right down by their feet. Okay, or down by their hips. Okay, now these are the air sacs, those clear things, not the lungs. Okay, so our first breath in, right, we're getting delicious fresh air that's being stored in all of these air sacs. A little bit like the frogs, right? Remember their first breath in, and everything went in that buccal pouch. Okay, so we're storing it in our butt. All right, so like before, when we store stuff in our air sacs, we need to get stuff out of our air sacs. All right, so this is a form of exhalation, right? You're pushing air out. Okay, even though we're pushing it out of an air sac. All right, so we kind of have to bend our thinking on how we imagine moving air around. Okay, so this is positive pressure, right? Because we're forcing or pushing air actively, right? So in this case, here we are, step 2. The air is in our butt, right, so to speak, all these air sacs in our femur or on our stomach. So we need to move the air from there to somewhere useful. Okay, now actively we want to move it to our lungs. Okay, so we need to squeeze all of the muscles that we have around those air sacs. Okay, all of our abdominal muscles, our hip muscles. Okay, to move the air from the air sac to our lungs. Okay, so this is how you know we're halfway there, right? We finally have oxygenated air in our lungs. With me so far? Okay, so this is a whole breath. Okay, we've taken air in, right? We've inhaled air, and we've exhaled some air, right? We've pushed air around. Might have to erase some of my birds, but we'll see. Whee! Jerk. Oh, I just want you to delete. There we go. Okay, so we see our first inhale, right? Went from outside to those posterior air sacs, right, to our butt. All right, exhale 1. Ooh, why are we not drawing? I got something on my stylus. Hang on. Sorry, guys. Or the screen has lost its mind, and I just can't draw in exactly that spot. So I guess that's fine too. All right, so for our second one, I don't know why that is. I'm sorry. All right, remember the exhale, so we're pushing air out, in this case out from the air sac into the lung. Okay, so we're oxygenating our lungs, right? This is where oxygen exchange would then occur, right after that exhale one. Okay, now, right, so the key here, man, yeah, something's wrong on that spot on the screen. I'm really sorry, everybody. Or there's something super wrong with my stylus. It's going to just make today super long. Just use my finger. Okay, so here in the middle, then, oxygen exchange has occurred, right? So the blood's come through. It's been able to take that fresh oxygen. This is really frustrating. Okay, exchange it for carbon dioxide. Right, so now we have a bunch of carbon dioxide in our lungs that we need to get rid of. All right, so now out is the rule of the game. So let's switch over to blue. All right, so inhalation 2, we need to move that air out to another air sac, right? So we can move this out of the lungs, right? Because in the background, right, we know that we need to continually keep fresh air in the lungs. We need to get the dirty air out of the lungs, right? Because in the background, every breath we take will also continue to move fresh air in the lungs. So our inhalation 2, right, remember we trade off negative pressure, positive pressure. So now we need another negative pressure movement. So we're going to use our costal muscles again. They seem to be working. Increase our chest. Okay, air pressure is going to move. Okay, so we'll increase our chest size. This will increase the space, allowing that air to move. And this is now going to move and fill up all of the anterior air sacs, meaning all of the air sacs in the head side of our bird's body. Okay, so remember seeing these in our pigeons. These would be in the thoracic half, okay, so just above where the lungs were. And there's also air sacs literally in the top portion where the wings are, up by the shoulders. These were very hard to see. Okay, and again, there's another 2 to 4 up here. Okay, now these are all stored with dirty air. Okay, literally carbon dioxide instead of fresh oxygen. Now, we've got stuff filled with carbon dioxide at this point, and it's in an air sac. So once we've got everything in an air sac, then we can go to our exhalation. Okay, in a true, what we kind of imagine an exhalation being. And now that it's in an air sac, and remember we're alternating, we just did negative pressure breathing, which means we're going to go to positive pressure breathing. And remember, anytime we're in an air sac, the solution of dealing with this is just to squeeze it out, right? Just like we did with that frog. So here we are in our air sac. We want to squeeze this out. And in this case, literally out. Okay. So our fourth and final step, right, our second exhalation, when we do positive pressure breathing, right, we're going to squeeze all of our muscles. And this is going to squeeze that anterior air sac. And in this case, we're going to blow out all that dirty air. So it takes us 4 steps to get from fresh air all the way down through our lungs and out. Okay, but every time we move, right, we're constantly getting fresh air cycling through the whole body. Okay, so birds are these creatures that are using pretty much everything we've learned about respiration all in one go, right, to keep their lungs very well oxygenated, and then by proxy, right, their muscles very well oxygenated. Okay, lots of steps to bird respiration. So any questions about the many steps, positive or negative respiration, right? Or the trade-off between air sacs and lungs in order to get us all the way through from in to out with the air. Okay, we'll finish up with that. The last thing I want to talk about then is, remember, the goal here in respiration is oxygenating the muscles of the bird. Okay. Largely, we've been talking about flight muscles, right? Our whole story here has been about flight, but certainly not exclusively. So when it comes to bird muscles, we can really pull these into two types. And this is generally when it comes to muscles. There are really two types of muscles. We call red fiber and white fiber muscles. Okay. Red fiber muscles, okay, are called fast twitch muscles. Okay, they're more like the dark meat, so to speak. So our dark muscles, our red muscles, are like high gear muscles. This is why we call them fast twitch. All right, so both of these, as we've talked about sort of like with everything, there's always a great trade-off. So the huge benefit to being a red fiber or a fast twitch muscle is you're fast. Right, so you have a much quicker response time to whatever is going on around here. Okay, so this case, when we're talking about quicker response time, we're talking about rapid limb oscillation, right? So you can either flap or run more quickly. Okay, so we might think of something like our little songbirds tend to have these, right? Quail have these sorts of things. Now, comparatively, we have animals that have, or some animals have both, right? Legs versus wings, have white fiber muscles, or what are called slow twitch muscles. Okay, the difference here, or the trade-off, right, is these have a much slower response time. Okay, it takes a slower or a longer time to get these to go, right? Takeoff is slower, running away is going to be slower, okay? But the benefit here is they're stronger, okay? And you can use them for a longer period of time, okay? And this is really the key, without tiring. Right, so these tend to be your long flight muscles, okay, or in birds that are going to migrate. Okay, so this is why a lot of your wing meat tends to be white, right, because most flight muscles need to stay in the air for a long period of time. Right, so it's not about necessarily needing to take off as fast as possible, which can be helpful, but I need to stay in the air for a longer period of time. These cannot tire very fast on me or I'm going to die. Okay, so these muscles need to have that extended use strength advantage. Okay, these need to be endurance muscles. So these are going to be slow twitch muscles.
So birds will have both, right?
Some birds have both, right?
But like, so if a bird is like a migratory bird, they basically only have white fiber.
Most migratory birds will have, at least they'll have the white fiber in the breast and wing area. Mm-hmm. Some birds will be split, so their legs, for example, will be the red, and then the breast and wings will be in the white.
And so like predatory birds will probably have more red fiber.
Yeah, yes, and you're correct that many predatory birds are more red fiber, right, to get that speed advantage for short burst activity. Excellent. Right, but they're also less likely to be migrator and going long distances. Okay, these are the main bird characteristics we want to go over. I want to talk about bird song here in a hot second. Is there any questions about any of this? Oh, I actually have this here. I'm just kidding. I thought that was my other PowerPoint. Okay. So the other thing we want to talk about with birds is song. So everything we've talked about with birds up to this point has really been about flight. And that really is one of the major things, of course, that sets aves apart. The other thing that sets aves apart is the way that they communicate, which is via their singing. So singing for birds is very unique. All animals do have some form of communication, but bird song is special, right? They have a special additional voice box type feature that allows them to get this complex type of communication that they use called the syrinx, which gives them levels and allows them to produce multiple notes at the same time, right? A feat only certain humans tend to manage. And singing is a very interesting piece, right? It's energetically draining. It's very loud, particularly given their size. And it has a benefit and disadvantage, right? Like so much of what we talk about, right? Because it is so piercing and it is so loud that it tends to alert predators to their space just as much as it provides the benefits that they gain, right? Which is, in part, right, gaining a partner, okay, as well as communicating with those within their nest, right? So I can initially attract and impress my partners, and this is why we see such complicated songs. This is a course of sexual selection. The more complicated my song is, obviously the more fit I am, right? My memory is better, my performance is better, my genes are much better. Come make a nest with me. And then once we make a nest, this allows us to communicate. And then when we have eggs, we can start teaching that to our offspring in eggs and start giving them a leg up both on recognition and on learning. Okay. In addition, right, if you've ever gotten too close to a bird's tree or a bird, right, they'll just scream in your face, right? So singing works against those that they see as a threat, both against things like us, but also against each other, right? So they tell each other, what's up? This is my space. This is my nest. This is my lady, right? Birdies don't do peeing on trees. It's all done vocally, right? So auditory tree peeing, so to speak. So song ends up being one of the most important things to birds as far as communication goes in pretty much every aspect of their life, despite the potential dangers. Right? And of course, they use that to tell each other of potential dangers as well. So what we're going to do to finish up talking about birds is to look at a handful of very specific bird songs and use them to start comparing against the different organisms that are local to the area and help identify some of them. I want to make sure I'm not going too fast. Does everybody have what they want off of here? Because I have to hop off this particular PowerPoint before moving on.
Are birds monogamous? One partner for their entire life?
That's a good question. So the question is, are birds monogamous? And the answer is, it depends. So some species are fiercely monogamous in that they will find one partner when they were very young, and if their partner dies, they will also die. Okay. Other birds, like they'll be monogamous for a year or two. Other birds just rack up a harem or cheat on each other. So it's very species specific, the answer to your question. And very interesting, depending on the species of interest. And some very much are. Yep, and I'm going to have to adjust the sound, so please forgive me, but at least it's working. My intent is not to have it scream at you, so.
Fast, cheerful charmer, song of the eastern bluebird. Fast, cheerful charmer, song of the eastern bluebird.
These are kind of quick, so some of them will repeat a couple times.
Squeaks and cat-like of the catbird. Squeaks and cat-like of the catbird. What cheer, 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 cheer. Whistles of the northern cardinal.
It's like therapy, just listening to this woman talk.
What cheer, 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 cheer. Whistles of the northern cardinal. Bubbles of the brown-headed cowbird. Bubbles of the brown-headed cowbird. Mournful hula hoop 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 of the mourning dove. Mournful hula hoop 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 of the mourning dove. Warbling song, potato chips, flight call, and baby of the American goldfinch. Warbling song, potato chips, flight call, and baby of the American goldfinch. Raucous dang, dang calls and car alarm of the blue jay. Raucous dang, dang calls and car alarm of the blue jay. Killdeer, killdeer of the killdeer. Killdeer, killdeer.
Okay, make sure that you finish off your Socrative. It looks like most of you have. And then when you are set, you are good to go. To the maniacal yodeling.
Haunting, maniacal yodeling of the common loon.
There's an exact subset in this file that I have up, and this is just a yes, if it's not already. Okay. If it's not, I think it is.
Haunting, maniacal yodeling of the common loon. Two-part Phoebe, call of the eastern Phoebe.
The bird calls.
Two-part Phoebe, call of the eastern Phoebe.